Ross. I'm the community manager for the enterprise.NET and mobile communities in North America.
My name is Alexandru Savu. I'm a community manager. I'm coordinating the enterprise.NET community in Romania.
My name is Matias Baldi, and I am the .NET community manager for Buenos Aires, Argentina.
So the purpose of the .NET community is to bring all of our .NET developers together under a common community where they can collaborate and share knowledge and information. The goal is to not just use training, but also use the knowledge of each other to help to grow everybody's abilities and thought leadership in the community.
To offer support and growth and trust, to create an environment where each and every one of us feels part of something bigger. So in the enterprise.NET community, the total headcount would be close to 200 engineers across Romania right now.
Currently, we are 65 members here in Argentina.
Right now in North America, we have 85 members who are part of the .NET community.
What's really the most exciting part of being a member of the community is that, for me at least, it's a full circle experience. Now I'm able to lead by example, to mentor other colleagues in the same way that I was helped and mentored by my peers before me.
Well, participating in the community, the people gain experience, they improve their technical skills, and also we have several programs to improve their communication skills. We try to create demos or create presentations emulating a client situation or a project situation. And then we create a career plan for them.
When you're working closely with your client, a lot of times you can feel more connected to your client than your organization as a consultant, and that disconnection can be a challenge sometimes. So the community's goal is that we're here as an organization to provide that network and that connection back to the organization, so people have a sense of a home and they know that no matter what happens in the different projects they work on, they always have a place of belonging here in the organization.
First of all, I have to say that I'm an introvert, right? And this creates all kinds of issues when I have to deal with client communication or presenting something. And I received support and mentoring, was able to improve the skills of presenting with the help of colleagues from the community. We had no issue in understanding that nobody is perfect, and we can all support each other to become better. And that's what I always try to do with the community also, help them.
What is studio experience?
For me, studio experience means flexibility and creativity and more freedom.
Being able to work with my colleagues from a cool office building, and when I want to, also from my hometown at the seaside.
And for me, studio experience is choice. I'm in complete control of how I design my week.
Choice to create the right environment for me to be productive.
It means finally finding a balance between work and personal life. The flexibility offered through this hybrid working model allows me to design my workday around the roles I have to take on. And the optionality to go to the studios makes it even more enjoyable while there.
As you can see, getting back to the office literally is a walk in the park.
It's about enjoying the pretty cool offices while working on projects and having the option to work from home with my daughter when she's not feeling so well or she just wants me close to her, or when I don't feel like doing the commute that day.
All resulting in a better work-life balance, as by the end of the day it means more time with the loved ones.
And studio experience for me means trust. Trust from my company that I know better what works for me in terms of schedule and the surroundings while working.
Trust that I can do my job well from no matter what place.
It is a new experience, a better work environment with a better focus and better results.
Hello guys.
This year is going to be amazing.
Hey, I'm Madeleine from Biomare QA community.
PMO community Romania.
Enterprise.NET community.
I'm part of the web community.
And I'm in the DevOps community.
We'll dive into the product management in software engineering companies.
At Programmers Week, we have a full day dedicated to mobile technologies.
For the first time this year, Programmers Week will feature Cognizant Softvision Product Day.
We are steering the wheels of product and project management.
And I'm happy that we have amazing speakers presenting at this ThreeTier Programmer Suite.
There's an opportunity for you here.
If you can go any bolder, how do you go bolder in your career and how do you go beyond?
Go further, go bolder, go beyond.
Go beyond.
Go beyond.
Programmers Week 2021.
See you there.
I started in Softvision because a friend of mine, a colleague, told me about the way they work here, about the way they organize. We organize here as a community.
I feel really good working as a community because I feel more supported, and I think that all of us work as a team instead only different projects.
For my previous work, I was always like chasing people, chasing information, chasing someone in other team just to get what I need. And here in Softvision, it's not that way. All the communities are willing to help, are willing to provide an extra hand, an extra pair of eyes.
So one of the opportunities I love working within Softvision is our deeply connected international communities, from North America to LATAM to around Australia and Romania.
Cognizant Softvision offered so many opportunities for me as a coach. I've been exposed to so many different setups of teams, environments, clients, industries. It's just amazing.
When I came to Softvision and working in project management, I loved the opportunities it gave me of being able to work across different industries with clients to understand how we can deliver new projects in innovative fashions.
Or when I can talk about and hear about the stories our clients have about how our teams on the ground are actually changing their business. That's what keeps me excited and engaged.
Because together we become better. Together we face problems and we resolve them.
And one of the things I love most about being here is that no task I'm given is the same. Every day looks different. And I have been in a various amount of different roles, from in-house to agency side. And I can truly say that being here allows me to really flex my muscles in various ways that I never knew possible.
It's always the same, but always new in the same time.
It's just a vibrant community hub of problem solving, sharing ideas, and we bring those problem solving capabilities to our customers, giving richer solutions, and it's really amazing to be a part of.
What is a place to be? Cognizant Softvision. The place to be now and beyond.
Software is everywhere, and as software product engineers, we have a role in reinventing industry. Through software, we figure out new relationships, new connections, new operating models, new ways, new experiences. But how to align multiple teams into cohesive goals so that then they act as a transformational force, a single transformational force, where each team can define its journey to mature, to get help, and also help the teams around them, which leads to a high-performance team ecosystem that can actually transform culture and achieve those desired outcomes. So the question is, could we codify this into an ultimate team playbook? What is software can actually help us to codify? Value system, ultimate culture, that can translate into the best practices. They can help adopt, define the right processes with an evolutionary framework that keeps us honest and questions everything through data all the time, where we can define and pick the right metrics and measure what actually matters, that actually encourages the connection and growth of our people, their engagement, their career path, connecting the talent platform that we have to the outcomes that we want to achieve for our clients. And all of this, at the end of the day, fosters a transformational partnership with the impact that we want to affect, incrementally faster, bigger, better. A few years ago, we came up with this idea. Today, this is Game of Pods.
Game of Pods isn't just another team building opportunity. It has given us as engineers a place to connect with each other.
A place where we can share ideas and co-problem solve on different challenges that we are facing.
And co-develop our own selves to become the best for our client work.
With Game of Pods, it's very much about personal growth, but you are able to see across the board how your colleagues are growing and how you both are evolving to better serve clients.
It's a platform that was designed for us and set to carry the torch across the finish line, but it does it in a way that showcases to our clients at all stages that our communities,
our methodologies,
and it's enabled our teams to hit the market and achieve product desired outcomes faster.
So follow us on this journey. Our communities and pods are developing, testing, and growing it each and every day to bring it to agile teams all over the world. We can't wait to welcome you to Game of Pods.
Have you heard? Programmers Week is coming up.
September 13th through the 17th. But this year, we're going big.
We're going bold.
We're going beyond.
This year, in addition to all the amazing tech talks, keynotes, and discussions you're used to, we're adding in the Product Day.
Product Day.
Join us for a special edition to Programmers Week, Monday, September 20th, when we take our love for software product engineering to a whole new level.
You'll hear from product experts on the ins and outs of product thinking, the approaches, the technologies, and everything in between that are driving great software products around the world.
So join us and discover your faster path to product value with Programmers Week 2021.
Thank you very much for coming, and I hope you like this presentation. Expand your tool set, at least.
Programmers Week for me as a presenter was more of an opportunity that Softvision provided to exhibit both my technical skills as well as interactive skills, because I think it is very important in today's IT industry.
Programmers Week, it's been an exciting and a learning week for all the Softvisioners across the globe.
I think it's a good occasion for us to share some knowledge, to understand each of our communities.
I'm so excited about what happened here. It's a big event for us.
Keep learning and hold presentations.
How UX professionals thrive within cross-functional teams through learning.
Some of us have enough strength to build that kind of motivation to really jump from where they're standing to the top.
6 years ago, we started our annual tech event. This is to celebrate the hard work and dedication of you, our programmers, product and design experts around the world.
I'm glad to be part of Programmers Week as a speaker for the second time.
Why is Programmers Week important to me? Because knowledge is important, and sharing it is how we learn and grow.
Programmers Week is the place where I'm gonna start my rookie year as a speaker.
We could say it's sort of a party for people who are really curious about what happens in the software world.
Programmers Week is a place that gathers around the communities, is the place that takes you outside of your day-to-day routine.
Programmers Day is important because it recognizes us as people that improve everyone's lives.
Keynote type for so yeah, I took a lot of existing
Today, I'm very honored to be able to introduce a celebrity in the Microsoft ecosystem, someone I've greatly admired and respected for many years based on his significant contributions to the software industry. A recent acquisition to Cognizant Softvision, I feel very privileged to be able to work with him to push the boundaries of software product engineering for our team members and clients. Of course, I'm referring to Rocky Latka. Rocky's reputation precedes him, so for many, he probably doesn't need any introduction, but in the spirit of formality, I'm happy to share his bio. Rocky Latka is CTO and Engineering Guild leader at Cognizant Softvision and has been an open source creator and contributor for over 25 years. He's the author of numerous books on enterprise software development and regularly speaks at major conferences around the world. Rocky is a member of the Microsoft Regional Director Program and MVP program. So without any further ado, I give you Rocky.
Thank you, Sean. I appreciate that. Hello, everyone. I'm glad to be here talking about one of my favorite topics, which is software architecture. And Sean and I were just talking right before we came live about how this topic is, it does change slowly over time, but because it's not tied to any particular technology, it's not tied to Java or .NET or Python or, a lot of this is, you can't say it's timeless because we're always thinking, we're always evolving. And in fact, that's a lot of what I'll be talking about today is that evolution. But at the same time, it isn't like it changes every year or every 2 years because some new version of architecture came out. And so to me, this is a lot of fun. I love the topic in general. It's also a huge topic, talking about architecture. And so I'm trying in this talk today to really bring things to a level where we can have a broad conversation around some timely aspects of architecture, and in particular discussing what today I think is the primary, for a lot of people, silver bullet that a lot of us are pursuing, and that would be microservices. Of course, the thing is that there really is no such thing as a silver bullet. And I actually went out just for fun and pulled the official dictionary definition of silver bullet, and so I thought that was kind of interesting. But I've been doing this. I've been in the industry professionally, building and architecting software for around 30 years, I think, something like that. And there's always this a marketing push, a lot of hype around something that is going to completely transform the way that we build software. And while it's true, every one of these miracle cures have had an impact on the way we build software, we have yet to discover the one true way, right? The one thing that's going to change everything. And I look back at just 3 key examples out of my career. I've built most of my career on object-oriented design, object-oriented analysis, domain-driven design. My first book and Eric Evans's domain-driven design books, we wrote. We were, not that we're friends, not that we know each other, but we had similar thoughts and wrote a lot of the same content at the same time. Back 25 years ago or something. And it was when object-oriented technology was really ascendant, even though it had been around for a long time. The concepts, right, it had been evolving in C++ and Smalltalk and other places. But it wasn't until you get into the mid-90s when C++ and Java starts to show up a little bit. Well, John came into being at that point, and Smalltalk was a going concern. And the idea of object orientation, was theoretically going to save us from the developer shortage and what was often called the developer or software crisis at the time. And obviously, object-oriented technology has had an amazing impact on the way that we think about and build software. But it also wasn't the end of the road, right? And so, you go forward through time, about 10, 12 years ago, started this whole SOA, service-oriented architecture idea. And that was going to transform, there were people like object orientation is done for, use of components, it's all over, everything's going to be a service. And of course, it turned out that SOA pretty much crashed and burned. And I'll kind of touch on that some more throughout my talk here today. Nowadays we have microservices, which, and I should put a disclaimer, I plan to be a little controversial off and on in my talk, but microservices is really SOA. We're just taking another run at it. Hopefully this time with some slightly better tooling and maybe some lessons learned, but it's the same basic idea. And whether microservices crashes and burns just like SOA did, frankly, remains to be seen. It's also clearly the case already that microservices is not the be all and end all. It's not the answer to everything. It's a great tool in the toolbox, but it's just one tool. And then the other one that is emerging now, again, this has been around for a very long time, the idea of functional programming languages. There's a lot of enthusiasm out there for languages like F# and a variety of others that are functional in their nature. And they're compelling because functional languages happen to be really good in dealing with distributed computing, parallel computing, and basically they fit well into a service-oriented, highly distributed world. At the same time, it's a pretty heavy learning curve for a lot of folks that are maybe used to using objects and classes or procedures and functions. And so again, I'm kind of skeptical that functional programming is going to be any sort of silver bullet, but at the same time, even today, we can see where languages and frameworks in Java and .NET both, for example, have taken lessons learned or capabilities of some of these functional languages and incorporated them. And no, Java and Spring and .NET, C# haven't become functional languages, but we've taken some of the best ideas and so we can use them, and it's fantastic, right? Definite improvements, but incremental and certainly not the end of the road. So my point is that if there's no silver bullet, and I'm sure now there's not, right? If there's no silver bullet, then microservices by definition isn't a silver bullet. It's not the answer to every problem. And so then we have to step back and think, boy, how do we put this into some sort of context? And without dwelling on it over much, I just thought I would spend a couple minutes talking through my personal career history and the different platform kind of approach architectures that I've been exposed to. And I think a lot of people have had a similar road, I'm sure with many variations, but I started programming professionally back in the 1980s, and I was a microcomputer DEC-VAX programmer, PDP-11 DEC-VAX, and our user interface were green screen VT terminals, VT52, VT100, all driven based on text and what were called escape sequences to draw things on the form or on the screen. And the other big technology, and well, frankly, the big technology of the time were IBM mainframes with 3270 terminals. And there's some subtle but I think important differences in that the mainframe approach tended to draw forms, and forms would be submitted back for processing, whereas the mini computer world, the VAXs and HP 3000s and so forth, were all tended to operate on a keystroke basis. So every keystroke from the user was immediately sent to the computer. And so we were, in my world at the time, able to create highly reactive or responsive user experiences because we were processing every keystroke and could do predictive typing and all sorts of clever things that we were able to do that were generally difficult to do on any sort of mainframe setting. On the other hand, the mainframe folks had some, rich, powerful frameworks and tools. And so I'm not saying one was better than the other, but that was the state of the world. And it's also maybe more important that everybody at that point tended to be writing what we would today call monoliths. An awful lot of the software was written in COBOL or Fortran, maybe Pascal, BASIC, other languages like that. And it was all very procedural well, that was the word, procedural programming. And so without a great deal of discipline, it ended up usually becoming a mess of spaghetti. From there, at least in my case, I moved forward and started programming on PCs, especially as Windows NT came out in the early 1990s. Dabbled in C++, but that was insanely complicated. Thankfully, Visual Basic, SQL Windows, Power Builder all came out and provided high levels of developer productivity. But really, they all were just a way of writing monoliths on a PC. And all these tools tended to be very much focused around, procedural programming still, right? It's also the case that in the early 90s, we started as an industry realizing that we needed to have separate database servers from our clients. And so there was a big shift at the time into two-tier. And what two-tier at that point meant was the idea that we would write a monolith that would run on a PC that would then talk to some sort of relational database server. And there's some tremendous benefit to that. But let's face it, we were still writing monoliths. And so it's not, at least in my case, until we get into the mid 90s, around 1994, 95, 96. And again, this is around the time I got into writing books and doing that sort of thing. It was also the time the domain-driven design book came out, the design patterns, the blue and white book. So there were a lot of people putting a lot of thought at that time into how do we build software in the current hardware deployment world, but actually make it maintainable. And this was the time that the idea of separation of concerns single responsibility principle, a lot of these things started to come into being at that point in time. And so we really started, or at least I started, focusing a lot on what I at least tend to call layering my software. So it's layering the different separations or the different concerns to keep them separated, and being able to build maintainable, essentially maintainable monoliths, if you want to frame it that way. In 1996 is when Microsoft Transaction Server came out, and shortly thereafter, Enterprise Java Beans came out. Power Builder came out with an application server layer. So a lot happened in 1996 that enabled three-tier computing. And it's not like people weren't trying it before, but we had to write it all by hand. And this was the point at which true application servers really became available and functional. And so a lot of people continued to essentially write monoliths, only deployed in a three-tier model. And I'll get into that as I get further into my slides, but it turns out that if you are using a good, clean separation of concerns with layers, moving into this three-tier model works really much better. And from there, we get into an N-tier model where we tried all sorts of different ways to deploy chunks of our software. The cloud starts to become a thing. SOA starts to become a thing. SOA, like I said, kind of crashed and burned for most people. Some were successful, probably around maybe 3 to 5% of organizations that tried SOA actually got benefit out of it. Almost everybody else ended up using SOA-based technologies to create client-server apps, N-tier. And that's what I see today with microservices also. A lot of organizations are trying to build microservice-based solutions, almost all of which end up being, at the end of the day, they have all the characteristics of an end-tier application just based on microservice technologies. And so they don't get any of the true benefits of being what you would hope from microservices. And like a lot of those kind of, I guess I would say bastardized SOA models, a lot of these what amount to end-tier apps written with microservices are a lot more complex and fragile and expensive than they need to be, were someone to have just recognized up front that we were doing an end-tier architecture. Now, starting probably again 10, 12 years ago with the SOA model, myself, Pat Helland, and a variety of other people at the time, Clemens Vasters, were really pushing the idea of using asynchronous message-based communication. Because I think, well, in fact, I'm quite confident, were we to have done that with SOA would probably have been substantially more successful. And that's still true today with microservices. If you're doing loosely coupled message-based communication, ideally over an asynchronous channel, your odds of being successful in achieving goals around microservices are infinitely higher than if you're not. And but this is hard, and I'll touch on that again. So I'm not going to rehash. This is just to summarize. I went through monolith, essentially monoliths that were distributed with tiers. Really, it's that end layer. It's the separation of concerns that really is a transformative concept. REST, SOA, microservices are great, fantastic tools, but again, they're just tools added to our toolbox. So when I look at this slide in particular, I think, if I'm building if I'm architecting an enterprise solution, I'm not going to reject the idea of a well-architected monolith. So again, assuming that we're using separation of concerns and are carefully layering our software, I'm not going to reject that because it's a perfectly valid architecture that has a great deal of benefit and might fit the needs. I'm also not going to reject microservices because, again, it solves a certain set of problems. And if I have those problems, microservices obviously would be the answer. And in any case, I continue to be a strong advocate for async messaging as being a way of gaining a tremendous amount of value and benefit. But there's some barriers to this, especially just in terms of developer training and understanding how this works. And I think the technologies around async messaging are evolving, some of it pretty rapidly. So I have hope that it's going to become mainstream at some point as we get things like Kafka or various other event meshes that are built out. That become mainstream. Now, when I think about architecture, really there's a set of goals that we're trying to solve as architects, right? Ideally, we'd like our software to be maintainable and deployable and secure, and we would like to have it be, have cost of development and cost of maintenance under control over time. We want our software to be reliable. We want it to be usable, right? These are all goals that I think every architect sets out and says, these are good. These are what I aspire to as attributes in the solution that I craft in order to solve my current business problem, which is all great. But I think it's important to recognize that these tend to fall into different buckets. And these ideas are not unique to me. There's a lot of folks out there that have various thoughts along this line. But on the whole, if I start over on the cross-cutting concern side, there are certain aspects of architecture that we have to take into account and we have to apply differently depending on how we structure both our logical and physical architecture. So things like security will be, we have to have security. And how we implement security is going to vary depending on how we logically and physically layer and deploy our software. Usability is an important, critical thing, but really is probably less dependent on how we organize our software in a lot of ways, and more dependent on how well we understand the business problem and make the software match that business problem. So most of the rest of my talk will focus on the logical and physical layers of the architecture. And here's where a lot of folks, I think, get real, I would say, confused. Don't really think this through, because a lot of people are like, oh man, I need to do this, that, and the other thing in order to get scalability. Well, for example, I have to have microservices because I want scalability. Well, that's not necessarily true, right? We've had really high-end scalability using end-tier technologies for the last 20 years. Microservices are not the be-all and end-all to become scalable. They're just resting on top of a set of lessons and technologies that we've learned over the last several decades, and they're not even necessarily the best way to get scalability. The same with fault tolerance. There's a lot of ways to get fault tolerance. Probably the cheapest and best way in a lot of cases is to architect your software using async messaging, believe it or not. But there's a lot of other ways to do it as well. But all of those end up coming down to mostly physical deployment choices. Am I architecting my software so that I can deploy it and have horizontal scaling where I have lots of computers that are running the same code? Or can I have vertical scaling where I can have one or more really big computers that have lots of memory and CPU that are running my code, or a combination of both? In today's world, it's particularly trendy to have horizontal scaling, and I like horizontal scaling, right? The idea of, well, let's just throw lots of small computers at the problem, and if one of them or two of them crash, then we don't really care because we'll just throw a couple more small cheap computers at it. And this is truly exemplified by the use of containers and Kubernetes, and because that's the architecture that is enabled here. Is this horizontal scaling, which, if done right, can also give us fault tolerance, but it might complicate deployment, right? So you really have to think through whether you have a good DevOps story in today's world, because if I'm going to deploy a lot of services or components or containers or whatever we're going to call them, and I'm going to deploy them on dozens or hundreds or thousands of nodes, I'd better have a darn good deployment story and a darn good upgrade story and very good instrumentation and dashboarding in order to manage that. All of which deals primarily with physical architecture. Now, logical architecture, this is separation of concerns. This is layering my software and keeping my software organized and having consistent discipline, not only when I build the software, but over time as I maintain it. This is where I get maintainability. This is where I reduce the cost of building and maintaining my software. This is where I get testability of software. This is where I get agility in my software and my business, the ability to enhance or alter my software's behavior based on changing business requirements. Has nothing really to do with physical deployments at all. And so this is where I'll have conversations with folks and they're saying, well, my big problem is my monolith is too expensive to maintain. I'm going to go to microservices. And I just, try not to chuckle, because microservices is primarily a physical, it's a way of saying, hey, I'm going to break things out so I can physically deploy it on lots of little machines, which is inherently expensive and complex. And so the odds of microservices by themselves saving you a bunch of money is pretty much zero. But especially if you take your existing monolithic mindset and just say, I'm going to create a bunch of little monoliths, mini monoliths, and we're going to call each one a service. You're just, taking your problem and making it worse. So if you don't start with a good logical architecture and think through, how am I organizing my code? How am I separating my concerns to make things understandable and maintainable over time, and then applying it to either a monolith, an end tier, or a service-based model. You have to start with a logical architecture, then go to the physical architecture. So when I talk about separation of concerns, I'm really talking about, and I have for many, many, many years, this 5-layer model where we say, hey, we've got an interface, and that interface might be blinking lights, it might be text, it might be graphical interfaces, it might be HTML, it might be Android XML. It's just the interface. It's what the consumer sees. Behind that, we have an interface control layer, which is usually a controller or a presenter or a view model. And now increasingly, we're seeing this MVU pattern come out and be used in tools like Flutter, which is a nice variation on this set of patterns. And then behind that yet is the business logic, things like validation and authorization, calculations, manipulation of data, algorithmic processing. All of these things should be in a formal layer. And you might construct that layer using domain objects, which tends to be the area that I live in. But you might also use pipeline rules engines like InRule, or many, many other options. A lot of people use function libraries, basically taking some of the best ideas from Fortran and COBOL and Pascal and saying, hey, what was wrong with functions? They work great. Then behind that yet, at least I tend to try and maintain an isolated data access layer. And the reason for this is frankly largely defensive. If you look at over time in the Java and Microsoft platforms both, there's just this constant churn on how do I talk to my relational databases. And it seems like every couple of years, somebody comes out with a newer and better way to talk to databases. And we all have to scramble to change to an upgraded incompatible API or a new object relational mapping tool or whatever it is. None of which provides any actual business value, but you can't allow yourself to be left behind either. And so the more isolated the use of any data access APIs are, the happier I am, just because it helps minimize the impact of this constant churn that happens in our industry. And finally, at the end is the idea of actually storing the data. And whether that's in relational databases, NoSQL databases, where I started was ISAM indexed files. Interestingly enough, indexed files have seen a major resurgence in use because of their infinite scaling in the cloud, frankly. It turns out that relational databases, while amazingly wonderful, don't really scale easily to a global level if you're talking big scale cloud. But simple indexed files with a little bit of federation in the key, all of a sudden you've got global scaling. So it's pretty interesting how what comes around goes around, right? And then obviously there are always these orthogonal or cross-cutting concerns, things like security logging, instrumentation, and so forth. So let's take that 5-layer architecture, which is a logical architecture, right? I'm not saying anything about how it was deployed. And let's talk about ways that we can actually deploy it. And so the easiest way, obviously, is that all 5 layers are running on one physical device. And this has always been and continues to be common, right? Every time that you go and use your phone, you're running a whole lot of apps that are running just on your phone, right? If the app works when your cell data is not available, yeah, it's a one-tier app. In my career, I've been involved in writing multiple point of sale systems, and point of sale systems tend to also always be one tier. And you might say, well, how can that be? Don't they talk to servers? And they do, but they also are almost always designed so they can run. So if you're in a big box store and the power goes out, the cash registers, even the power is out, the networks are out, under every cash register is a UPS. So for about 15 or 20 minutes, those cash registers are now running in single tier mode, and they can continue to take your cash as you are safely escorted out of the store under the emergency lighting, right? So my point is that the single tier architecture remains very, very common, even though for most of us, we don't think of it as being sexy or trendy. A two-tier model also continues to be widely used. This really came into being, like I said, in the mid-90s, and solved a whole bunch of problems that we were all having because prior to that, we tended to, our quote-unquote databases were file-based systems using Access or DBase or whatever it was. And so corruption of data, and there were a lot of issues that went away when we were able to have true database servers. And yet we still wrote all of our applications to just run on one computer. The lesson that I would hope that we've all taken, or should be taking, is that just because I'm writing my software to run on one computer, whether in a one-tier or two-tier deployment, if I layer my software, I gain maintainability, I gain agility, and I gain the ability to keep my software relevant without developing overly large amounts of tech debt over time. Versus if I have no structure, if I don't do separation of concerns and I don't layer my software, I will end up creating a big ball of mud, spaghetti code, and we'll end up back in the bad old monolith days, which clearly none of us want, right? Now, in the mid-90s, we discovered that our top of the line 386 computers, or the Pentiums with the floating point error in the CPU, for those that remember those days, could only handle maybe 30 to 50 concurrent users in a lot of cases. And a lot of us were writing software that at least had hundreds of concurrent users. And so it turns out that a three-tier model, and I'll go through several variations on this, really solved the problem. So one way that was pretty common and popular back then and remains so today was the idea that I would use some technology. Let's say back in the day, it was PowerPoint or Power Builder. I might write a Power Builder app that's running on the client, the end user's computer. I might write all of my business logic in C++ on some sort of server. And then, of course, that server would talk to a database server. No, and this works, right? And we do this today. A lot of people are out there writing Angular or React apps that deploy into the browser that are following this model, and then they call some sort of app server. And that app server is probably written in Java or .NET or Python, whatever. And so as much of the business logic as possible is maintained on the server. And but the problem with this architecture is that it makes it very difficult to give the user a good experience. If every time that you need to validate a field or every little calculation, everything that you do, you have to round trip to the server. That's not really ideal, right? And so the other big three-tier architecture that has been used over all of this time is the idea that, well, maybe the business logic should be closer to the user. If I write a lot of my business logic in TypeScript with Angular, or if I use C# with Xamarin, I can run my business logic on iOS and Android, right, or Flutter. And now I can give the user a great experience because all of my logic is running right there on the device where the user's sitting. And so I can get this, even down to a keystroke by keystroke or tap by tap. Everything the user does can trigger business logic that's immediate and tactile right there. Give the user a great experience. And I still get all the benefits of 3-tier around security and scalability and fault tolerance, right? The drawback to this architecture, of course, is that there's some business logic that really needs access to back-end services or large amounts of data. Or maybe I don't trust the client device, which is pretty common, right? Who trusts a browser or even a cell phone? And so if I have the logic running on the client device, that maybe is not considered very secure. So I've given the user the best experience possible, but I've given up quite a bit in the process. Which brings me to the architecture that I tend to advocate for the most. And this is the idea of, why don't we figure out a way that we can run the business logic, or some or all of it, on the client to give the user this fantastic user experience with immediacy, and also run some or all of the business logic on the app server, so that I have security, scalability, I have access to server resources, and so on and so forth. And here's where technology does come into concern, because if you try to do this in kind of the modern web world, where you say, oh, I'm building my client side using JavaScript and React, then I'm building a lot of business layer or business code in JavaScript. Now, how do I run that same business code on the server? And the only real option then is to say, well, now my server is written in Node, so that I can run JavaScript on both sides, because I don't want to write and maintain the code twice. But in practice, that's actually what happens more often than not, right? Is I'm writing all of my app server code is written in C# or Java, and then I'm rewriting that code in JavaScript or TypeScript to run it on the browser. And then I have to write it twice, I have to test it twice, I have to maintain it twice. And when we talk about maintaining twice, we're talking about enterprise software. This is software that has a lifespan of 10 to 20 years. So that maintaining it twice, right, that adds up. For the next 2 decades, some poor schmuck is going to have to be maintaining and testing every line of business logic twice, right? This is horrible. And which is why if you end up saying, well, I am going to use JavaScript or TypeScript on the client, then you probably should lean toward using Node on the server. Fortunately, at least in my world, because I'm kind of Microsoft centric, I look at WebAssembly, and WebAssembly allows us to compile C, C++, and now C# code to run in the browser natively. And so it becomes very realistic to think, well, if my app server is written in C# and my client is written in C#, then I can create my business logic in one deployable DLL, one binary unit. And I only have to test it once, I only have to maintain it once, and I just deploy it to both the client and the server. Yay, right? Pretty awesome. And this, frankly, is the world I've lived in as much as possible. I would say since 1996, when we were first able to do this in any sort of meaningful way. The final thing I'm going to toss out is server-side web, the old-fashioned just server-based web, which is extremely much like, well, frankly, it's like the mainframe world, where the interface is just, in our case, HTML, CSS, and all of the logic is running on some web server somewhere. And we're just transferring essentially forms worth of data back and forth, almost one-for-one match to anything that we did, way back on the mainframe world. And I realize this has been the centerpiece of computing for a very long time, and a lot of people love and enjoy this. And I don't dislike it. I just never found it to be compelling, because I started my career in this architecture and then went into other models. And I'm like, oh, look, they reinvented the mainframe. Yay. It's just hard to get excited, at least for me. Now, you'll notice in that previous slide, I didn't put users or anything. I used the, in fact, I'll back up one. I used the word consumer in every case here. And the reason I did that is because when we are thinking about software architecture, we're not just thinking about software that's being used by a human. Our consumer for an application might be a user. It might be other software. It might be a gateway server, like an API gateway. It might be a messaging hub or other message broker. And so in fact, the odds, especially in today's world, the odds of me building software that is going to be used by other software is higher than the odds of me building software that's going to be used by a user. And my point here is that this architecture is consistent regardless of who's consuming my interface. And in fact, that transitions us into talking about, well, what does this architecture do in a service-based world? Well, if I'm creating services, hopefully I'm not creating each service as a ball of mud. Hopefully, when I create my services, I'm actually architecting my services to be maintainable and have all these other fantastic attributes, which means that when I build a service, I'm going to use separation of concerns, single responsibility principle, and I'm going to layer my code in my service implementation, just like I always have. And then I might deploy it in a one-tier model in a container running in Kubernetes. I might deploy it in a 2 or 3-tier model running in Kubernetes or AWS or whatever, right? And you might say, well, Rocky, why would you deploy a service in an n-tier model? But the answer, hopefully, is pretty obvious in that my service itself might need to scale, right? A lot of my services might not. They might be quite small and discrete and be able to just deploy and do something all in one spot. But other parts of my, especially at an enterprise level, you can easily envision services that are used consistently and constantly by thousands and thousands of concurrent users. And the service itself needs to scale in a way that might not be easy to achieve in a one-tier deployment. And so I don't want to tie my hands when I'm thinking these things through. I want these options available to me. Now, when I talk about, language becomes an important thing here. When I talk about all of this stuff, you think about, I use the word app, and then people also start talking about services. And the thing to keep in mind, and this is critical, is that a service is an app, right? A well-defined service, right? And both an app and a service are exposing some sort of interface. Both of them encapsulate some important functionality. Both of them, and this is the key, both of them are independently versioned and deployable. And this, in fact, is really the where I see kind of the break point with a lot of folks that do service-oriented work or microservice work, is if you can't deploy your microservice independently of everything else, then it's not really a microservice. Then it's just something else. Because the whole definition of a service, and this was true in SOA and it's true with microservices, is the goal is that I have this chunk of functionality that I can update, change, enhance, fix, and I can redeploy it independently of everything else. More often than not, what I actually see in real life is we've got organizations that create dozens or hundreds or even thousands of services, and they can only be deployed with all of the others. And so it's like, oh, now what we've done is we've taken what was a monolith that had to be deployed all at once, which was bad enough, and we've broken it up into 1,000 little pieces, all of which have to be deployed all at once. I mean, it's like, oh my God, what have we done to ourselves, right? It's a major faux pas. So again, I come back to this point that a service is an app, and the real point here is that if you're doing it right, you can deploy each service independent of anything else. This means that a service application makes no sense at all to say, oh, I'm creating an app that's composed of services. Well, that's literally the same thing as saying I'm creating an app that is composed of apps. And at that point, you can't have a conversation, because am I talking about the big app or each individual little app, or you can't even, words lose their meaning. So personally, I use the term service-based system. I say, I'm creating a service-based system. Every service is an app. Every app that talks to an end user is an app. And in fact, what we end up with, what we end up with are apps that have a user interface and apps that have a computer interface, an API. That's it. Those are the two kinds of things that we have. And I'm creating a system based on those building blocks. So inside an app, and this is true for an end user app or for a service, I'm organizing all of my code into layers. I might deploy it against tiers. I'm going to think about how I'm communicating between those tiers, but this is all isolated, right? I'm inside of what's called an app boundary. And so I control how I communicate between the tiers and layers inside my app. And I have some level of trust because it's all my code. Now, between apps, between services or end user apps that are calling services, there should be zero trust. Right. In other words, if I'm creating a service, I don't know, pretty much by definition, I do not know who is going to be calling my service. Therefore, I have to assume every caller is malicious. And so I should be treated as a black box. Nobody should understand how I work or what I do, right? Because that's inside the app. Anybody outside should only interact with my interface. They should never bypass me and talk to my underlying data sources or anything like that. And I'm going to have to choose an external communication mechanism that works at an enterprise level. So usually it's going to be some sort of JSON or XML-based protocol. Very inefficient compared to binary protocols, but what you're going to do. So this leads us to the idea that there are a set of apps. Ultimately, these are just different terminologies, I guess you'd say, for basically apps that have end users or apps that are being used by other apps. We also have this idea, which I touched on, and this is super important, is that between tiers, I might use remote procedure calls, and people often look at that and they go, RPC, isn't that something like from 20, 30 years ago? But most of us still do RPC. We just do it with HTTP protocols. But we're like explicitly calling and saying, hey, do this for me. Get this, post that, put that, right? We're very declarative, and we're passing in essentially a set of parameters, and we expect a specific result. That's RPC. We dabbled for a while with REST back in the SOA days, and a lot of people still say, oh, I do REST, but you really don't. Most of us, when was the last time that you built an Atom feed? When was the last time that you either accepted or replied a payload that had some sort of HTML links in it, right? The whole point of REST is that I give you a document, and now you can navigate and manipulate and do interesting things with that document. We don't think that way. Almost nobody does. I'm giving you a result from you. You called me, you asked me to do some work, and I'm giving you a result. Really, that's not a document that I'm giving you back, right? Now, this is fundamentally different from messaging, where with a message, it's a request. So both RPC and REST tend to be command-based. It's like I'm the caller. I'm going to call you and say, hey, get this for me, or post this for me. I'm giving you an order. And whereas with messaging, it's the reverse. I'm composing a message, I'm sending it to you, and I'm saying, hey, would you please do this for me? And as the recipient of a message, you can actually give me back one of three different responses. You can say, I got the message and I did it for you. Yay! I got the message and I can't do it for you. I'm sorry. Or I got the message and I don't understand, right? I mean, I'm going to not service this message. I can tell you that I refuse, and that would be an error. And that pattern applies into an async messaging world as well. It's just when you switch from a synchronous to an asynchronous model, you get a whole bunch of benefits around fault tolerance and scaling for very little cost. So just to drive this home in the last couple minutes that I've got, here is an example of an N-tier app where you can see the app boundary. So my user is interacting through a browser, through a phone, whatever. The client device is then talking to an app server, and the app server is talking to a database server. Inside my app boundary, I might be using HTTP, I might be using messaging. Nobody should care, right? Mostly we use some sort of an RPC protocol, maybe based on HTTP, but now here is an example of a service-based system. So the same idea, the end user is talking to an app on their phone or their browser. Notice that the app itself is still layered, right? And then it is calling an API gateway. And so that protocol between the Edge app and the API gateway is almost certainly going to be some public web standard. It's going to be HTTP. It might be somewhat RESTful. But basically, we're going to use the kinds of protocols that exist and work well on the internet in a public sense. Once we talk to the gateway, now the gateway is going to delegate all of the work to a set of services. If I were designing this, then I would say all of my services are going to communicate through async messaging, either through some sort of event grid or Kafka, or just something simple like RabbitMQ or Azure Service Bus. And each of my individual services are a standalone app that's going to do something. And they will be triggered because of a queued message arriving. And then they're going to do some work. And then when they're done, if they have a result that they're going to send out, they'll send it as a queued message to either other services or back to the gateway. So the gateway can update the end user Edge app. Now, there's nothing wrong with doing a combination of these things. And I think actually this is the way to go. So you say, well, my end user is talking to just an N-tier app that's doing its job, because N-tier apps are cheap, easy to build, well understood, and have a whole bunch of benefits, including scalability and so forth. However, it's possible that part of my logic has to change on a regular basis. I'm constantly having to change the algorithms or tax codes or insurance calculations, whatever it might be. And I don't want to redeploy the whole app every time. So my app server is going to rely on one or more services to do the work that has to be redeployed maybe on a weekly basis because of business changes. So this way, the bulk of my app gets deployed and runs on a fairly stately basis, right? But the parts of the app or one or more little parts that have to be refreshed all the time, I can refresh constantly. And this can get more complex. Instead of just one little service, it could be a whole domain of services. At an enterprise level, I might be interacting with multiple domains of services, where each one of these little service bubbles might be, one of them deals with customer data, another deals with product data, another deals with pricing, and yet the fourth deals with inventory. So ultimately, what I would hope that you take from this is, I think we should always employ separation of concerns. We should always carefully layer and think through logically how we're organizing our software, because that's what gives us maintainability and cost management. Then you say, okay, now that I've done that, how do I want to deploy? Do I want to deploy as a set of tiers? Do I want to deploy as a set of services? Do I want to deploy some of it in a tiered model and some of it in a service model? I can pick the right tool for the right job and mix and match as needed. At the end of the day, what I really think we all need to do is be self-aware. Don't pretend like you're doing microservices if you can't, in fact, deploy each of your services independently. You're not. Then you're doing some sort of end-tier thing. And that's fine, but recognize that you're doing an end-tier thing so that then you can actually do it correctly, right? Trying to say, oh, I'm doing microservices when you're accidentally doing end-tier is probably not the best route, or doing end-tier when you're accidentally doing microservices. I'm not even sure that's possible. But the point being, whatever you do, recognize it, understand it, and leverage its benefits. And I think that, if there is anything here, that would be your silver bullet. Thank you all so very much.
What is studio experience?
For me, studio experience means flexibility and creativity and more freedom.
Being able to work with my colleagues from a cool office building, and when I want to, also from my hometown at the seaside.
And for me, studio experience is choice. I'm in complete control of how I design my week.
Choice to create the right environment for me to be productive.
It means finally finding a balance